When a teenager is hit in the head, his brain can begin to show signs, within days, of the kind of damage associated with degenerative brain disease, according to an unsettling new study of young men and head injuries. The findings, which also involve tests with animals, indicate that this damage can occur even if the hit does not result in a full-blown concussion. With the Super Bowl taking place on Sunday, the issue of head impacts is on many of our minds. It is well known, of course, that some deceased football players' brains have shown tissue damage and spreading clumps of a protein called tau that can strangle and kill brain cells. This brain condition, called chronic traumatic encephalopathy, or CTE, is thought to be caused by blows to the head, including the kind of impacts that occur frequently during tackle football and other contact sports. These impacts often lead to a concussion, a brain injury characterized by a multitude of symptoms, such as headaches, dizziness, wobbly balance, and changes in attention and memory. For many of us who watch, play, or are the parents of young athletes in contact sports, concussions are a great and growing concern. But surprisingly little is conclusively known about the relationships between head impacts, concussions, and CTE, or about how quickly or slowly a head injury might begin to shade into early signs of disease. Those precise questions have gripped a large and distinguished group of scientists at Boston University School of Medicine and many other institutions around the world. These researchers were among the first to identify CTE in the brains of football players and later in soldiers who had experienced blast injuries to their heads. Their work has established strong links between such hits to the head and later CTE. But for the small new study, which was published recently in Brain, they hope to learn more about how and how quickly such injuries might contribute to the disease. So they turned to what were, frankly, a series of tragedies. The brain bank at Boston University had come into possession of brains from 4 teenage athletes, each of whom had died within days or weeks of a head injury experienced during play. 2 of the young men had killed themselves. The scientists do not know if their head injuries had contributed to their suicides. The other 2 had died of brain swelling that most likely was related to second impact syndrome, which can occur if someone experiences 2 head injuries within a short period of time. None of the individual impacts was serious enough, in and of itself, to have caused death, says Dr. Lee Goldstein, an associate professor of psychiatry at Boston University School of Medicine and the study's senior author. But when the researchers closely examined the young men's brains, they found more harm than they had expected. The teenagers' blood-brain barriers, a natural defense system that keeps harmful substances from entering the brain, appeared to have been damaged, and many of the small blood vessels throughout their brains had sprung tiny leaks. 2 of the brains showed disquieting accumulations of tau proteins near these broken blood vessels, and 1 brain had diagnosable stage IC.T.E. This was the first time that scientists had found signs of incipient or actual CTE so soon after a brain injury and in people so young. But since so many other factors might have contributed to the brain conditions, from genetics to earlier hits to the head, the researchers next decided to look at similar head impacts in animals and track precisely what happened inside their skulls. Using young male mice, they applied relatively mild jolts, designed to result in a sudden, strong jerking of their heads, much as occurs during head-to-head tackles and other impacts. Afterward, some animals showed symptoms of a rodent version of a concussion, stumbling and performing poorly on memory tests. The scientists then injected some animals with a dye that cannot cross a healthy blood-brain barrier and scanned the living animals' brains. In about half of the mice, they saw signs of the dye in their brains, indicated that their blood-brain barriers had become permeable. Many of the mice also showed signs of leaky blood vessels and other damage, including inflammation and disruptions in the electrical activity within their brains. Some had early signs of tau accumulation. All of this had occurred within days of the head impacts. But, interestingly, the damage was not closely associated with concussions. The animals that had developed concussion symptoms were rarely those that showed damage during the brain scans. So some animals had developed concussions despite having little discernible brain damage, while others had experienced damage typical of CTE without showing any symptoms of a concussion. The upshot is that we probably have raised more questions than we've answered, Dr. Goldstein admits. Principally, those questions center on whether the current focus on concussions in athletes, and the rest of us, might be too narrow. Dr. Goldstein says it looks like it's the head impacts that matter. He says, whether or not they result in a concussion. But mice are not men, or women, who were not part of this study because, blessedly, no brains from deceased, young female athletes were available. So whether the effects observed within the animals' skulls exactly replicate those in people is unknown. The study also cannot determine whether older or younger brains respond the same way to injuries, or why some brains, in both mice and men, seem especially susceptible to mild trauma, while others, after the same hit, remain healthy. Perhaps most important, this short-term experiment cannot tell us whether brains that show incipient signs of CTE will necessarily go on to develop the disease.